evaluate this line integral, and the integrand is 2x square minus y square dx plus x square plus y square dy, where C is the boundary of the surface in the xy plane enclosed by the x-axis and the semicircle y equal to square root of 1 minus x squared. Now as the integrand is of the form p dx plus q dy, so we need to apply the Green's theorem over here to evaluate this line integral. So let's take the region R which is enclosed by this curve C. So let R be the region enclosed by the curve C. And what are the two functions? It is 2x square minus y square and x square plus y square. Both these are polynomials. So these are continuously differentiable functions. These are continuous and also the derivative exists. So these two functions are continuously differentiable functions. So writing this, since 2x square minus y square and x square plus y square are continuously differentiable functions in the region R, so therefore by Green's theorem the given integral is equal to the double integral over R taking the partial derivative of q with respect to x. So this is curl of x square plus y square with respect to x minus partial derivative of p, that is 2x square minus y square with respect to y, and writing here dx dy. So when we partial derivate x square plus y square with respect to x, we are getting 2x. And when partially derivating 2x square minus y square with respect to y, we are getting minus 2y. And because of this negative sign, the integrand becomes 2x plus 2y. Is it okay? Fine. Let's write this. And now we need to write the limits for x and y over here. Now since it is given to us that the surface is enclosed by the semicircle y equal to square root of 1 minus x square, squaring both the sides we get y square equal to 1 minus x square, or it is x square plus y square equal to 1. That is the unit circle in xy plane, right? So this is your circle x square plus y square equal to 1. But the surface is enclosed by the semicircle, that is the upper half part. So the limits of x is from negative 1 to 1 and the limits of y is from the origin, that is from 0 to, okay, if I take this to be any point on the surface, if I take this to be the point on the surface, what is the value of y at this point? It is 1 minus x square under the root. So the limits of y is from 0 to square root of 1 minus x square. Is it fine? Yes? Okay. Because I'm having the limits for y from 0 to 1 minus x square under the root, and the limits of x is from negative 1 to 1. The limits of x are constant. So we have to take the limits of x on the outer integral, and for that I need to replace these two. So this is dy dx, and now writing the limits for y, that is from 0 to 1 minus x square under the root. Please remember the variable having the constant limits should be on the outer integral. So let's continue further. So this is equal to, now integrating this with respect to y first. So integration from minus 1 to 1, and integrating this integrand, this becomes 2xy plus 2y square divided by 2, that is y square. Yes. And the limits from 0 to 1 minus x square under the root, and writing here dx. Now putting the upper limit for y in this integrand, we get 2x into square root of 1 minus x square plus for y square we get 1 minus x square minus putting the lower limit on y we get 0 and writing here dx. So the integrand is this only. Splitting this integral into parts for these two terms now. So this is equal to the integration from minus 1 to 1. The first term is 2x square root of 1 minus x square. I am taking 2 outside, so this is x into square root of 1 minus x square dx. And then plus sign the integration for 1 minus x square. So plus the integration for the integrand 1 minus x square dx. So this is equal to, now because this is your odd function, yes, this is your odd function. So integration for this odd function, because it is having the equal and opposite limits, so this integration is 0. I have used the result. Plus, this is your even function. And whenever we are having the even function with equal and opposite limits, the integration will be changed into twice of integration from 0 to 1 and the integrand 1 minus x square dx. So this is 0, so I am writing this twice of integration from 0 to 1, 1 minus x square dx. Now integrating this with respect to x we get, okay, integration for 1 is x minus integration for x square is x cubed divided by 3 and the limits from 0 to 1. So this is equal to twice of, okay, putting the upper limit for x, it is 1 minus 1 by 3 minus putting the lower limit for x, it is 0. So this is twice of 1 minus 1 by 3 is 2 divided by 3 and we are getting this to be 4 divided by 3, which is the required answer for this line integral. So we have evaluated this line integral to be equal to 4 divided by 3. Okay, thank you. Stay blessed.